My name is Iqbal Khan. I am a technology evangelist at Soft, which is the maker of this product called NCache. How many people here have heard of NCache before? Good. But 20%, I think. So today's topic is how to scale entity framework applications with distributed caching. I prefer to keep this a more interactive session, so that if you guys have any questions, just raise your hand and then I'll take your question. That way we'll have probably more meaningful discussion. I'm just going to go through a few definitions just to make sure everybody's on the same page. For those of you who do not know what entity framework is, it's an object-relational mapping engine for .NET. It simplifies your database programming. You can work at a conceptual object model instead of doing the ADO.NET level programming. It cuts down your development time, and it's becoming really popular. We're seeing a lot of activity in the entity framework. It used to be that NHibernate was the more popular engine. Have you guys heard of NHibernate? Okay, so that was the open source implementation of the Hibernate, which came from Java. So with entity framework, I know some of this is going to change in EF7, but up until now, you basically have all the models in the mapping in an EDMX file. There's a conceptual model, which contains the entities and relationships. There's a storage model, and there's a mapping. And then there's an object services layer. If you see the picture here, there's an object services layer that deals with this entire model, and then the application issues linked to entities or entity SQL queries into this. Most, or in fact, entity framework applications are dealing with data coming from a relational database, most of the time SQL Server, but it could be another database as well. These applications often need scalability, and this is where distributed caching comes in. Again, a few more definitions. Scalability is something where you just want really good performance even when there's a lot of load on your application. So if you just have only 5 users and your application is performing really well, it doesn't mean that your application is scalable. It's only when you have 5,000 or 50,000 or whatever that really high number is that you'll actually start to see what the value is. Just one sec, I forgot to do something, my apologies. I'm supposed to record this. Start this so that we can. Okay. Following applications need scalability. These are usually server-side applications. These are ASP.NET applications, web services. These are the two most common, but you may have other .NET server applications. There's big data processing, which is another up-and-coming use case, but that usually does not use entity framework. That's why I did not put it here. So how many of you have ASP.NET applications in your groups here? Pretty much everybody. Okay. So the reason you need distributed caching is because there's a problem that exists. And the problem is that your applications are unable to scale even though your application tier scales very linearly. The data storage, which is your relational database, becomes a bottleneck. Because the relational databases, by design, do not scale. There are some recent attempts for in-memory databases to make them more scalable, but most databases still have a scalability issue. For example, you could have a picture here where you could have more and more servers at the application tier, but you cannot add that many servers or servers in the same fashion at the database tier. And NoSQL database, although it solves your scalability problems, but it's not something that you are able to go to a lot of the times. And the reason is because either for technical reasons or for business reasons, you just cannot move away from relational databases. There's a lot of dependency. There's a whole ecosystem that exists around the relational databases, and it's a pretty big move to move entire data to a NoSQL. So if you are able to move to NoSQL, you don't face the scalability issues that relational databases give you, but you're just not able to move. So in a lot of the situations, they don't provide you the answer. So the answer really is a distributed cache. NCache is one example of that. There are other caches also. Redis is being used by Microsoft in Azure. So a distributed cache is distributed, and that's why it's scalable. And the nice thing is you can use it with a relational database or your legacy mainframe data. You don't have to abandon those databases. And here's a picture. So for those of you who've never used a distributed cache, this is how it actually looks like in a deployment. You have your load balanced application tier. This is not always flat. It could be that the web tier is the front end and it's calling the web services tier. Maybe the web services tier itself is the front end. It's calling some other web services tier. So there's a whole, a lot of permutations that exist. But the fact is that the application tiers are scalable. You can add more and more servers. These are usually load balanced. So there's a load balancer in front here, which I haven't shown in this diagram, which routes the traffic in an even fashion to all the servers, so that that's how they can handle more load. And that's how you can add more servers to scale. And then when you want to put a distributed cache between the application tier and the database, it looks just like this. It is usually 2 or more servers that exist between the application and the database tier. And a distributed cache, in case of NCache, it builds a cluster. It's a TCP-based cluster. And the reason it builds a cluster is because all these servers need to know about each other, so they can work together in a more collaborative fashion, so they can pool the resources. The resources are the memory, the CPU, the network card, and that's how the scalability happens. And the pooling of the resources also sometimes includes data replication, because it's a redundant, there's a redundancy built into this layer so that no data loss occurs. So when you have a caching layer in between the application and the database, it traps about 80% of your traffic. Now this picture is slightly misleading because it is implying that all your database interaction is going to go through the cache. That's the read-through model, but that is not true. Most people keep this cache on the side somewhere here, and they go and talk to the database. Then whatever they get from the database, they put it in the cache. So the next time they want something, they first look up the cache. If the cache has it, they don't need to go to the database. And because the cache is so much faster than the database, it's very scalable. It never becomes a bottleneck. The application never has any bottlenecks. So if by putting in a distributed cache in your application architecture, you will ensure that your application will never slow down. And the cost of a slowdown is really, really high. The reason is because the slowdown happens when your business is really doing well, when there's a lot of activity, a lot of customers coming to your application. And if it's a customer-facing application, or even if it's an internal application, when a lot of people are using it, that's when the slowdown occurs. So any And a slowdown can also lead to the whole system crashing. And when that happens, of course, the cost is very high. So by putting a distributed caching layer in between the application and the database, you ensure that you'll never have that bottleneck. These cache servers are typically pretty inexpensive boxes. These are 64-bit boxes with a lot of memory in them. 16 gig seems to be the standard in case of NCache in each cache server, but it could be more or less depending on your need. So the amount of memory is dependent on how much data you need to store, because the storage is memory. These are usually like dual CPU type of configuration, same configuration as your web server. So these are not database server configuration boxes. So that's why they're really cheap compared to databases. Any questions at this level in terms of this deployment?
Can these boxes be Linux boxes or does it have to be?
Yeah. So the question is, can these boxes be Linux boxes? In case of NCache, no. These are, because NCache is a purely .NET product, so everything is Windows. In case of Redis, Redis is primarily a Linux-based product. Even Microsoft is using it in Azure, but the cache actually runs on Linux. So it depends what cache provider you use. There are also cache, or what in the Java world, they're called in-memory data grids. And they're all Java, so they would run on any platform. So that's the answer. But the client can either be .NET or Java. Even in case of NCache, it could be either .NET or Java. The cache itself has to run on the Windows. Any other questions? Okay. I'm just kind of establishing the case on why you need caching, and then we'll go into how to use it in Entity Framework. Here are some scalability numbers. With a cache server, with a 2-node cluster, you can do about 50,000 operations per second, 32,000 updates. These are NCache numbers, and then as you can see, they're scaled in a fairly linear fashion, 50,000, 72, 96, 120,000. These are pretty good numbers based on most application needs. And is that linear line that ensures that your application will never slow down. So if this were a logarithmic curve, which was that as you went down this, the curve sort of went like this, then it would not be a scalable solution. Okay. So that once you decide that you're going to use a distributed cache in your application, there are 3 different ways that you can use it. I'm going to focus mainly on the first way, which is the entity framework based. But the first is application data caching, which is the data that comes from your database. You cache that one. The second is the ASP.NET specific caching, which is your session state, your view state, and the page output. Session state is something which is very commonly kept in cache these days, especially in high traffic environments. It gives you replication, and all the session state storage options that Microsoft gives you out of the box are not feasible for a high transaction environment. So a distributed cache allows you to cache it or store it in a very meaningful way. The view state, if you don't have MVC framework, view state could be pretty expensive. This is an encrypted string that gets sent to the browser, and when you do an HTTP post back, it comes back to the server. So it's a pretty expensive trip going from the web server to the browser and back. It consumes a lot of bandwidth. Bandwidth is not free and also slows down the application. The same impact is for the page output. The third common use case is, which a lot of people don't know, which is runtime data sharing through event in a pub-sub model. So if you see these 3 use cases, there's something peculiar. In the first use case, the data exists in 2 places. So everything that you do in caching has to factor that into your use, which is when the data exists in 2 places, one is in the cache, one is in the database, what's the most sensitive thing that comes to mind? What could go wrong? Yeah, so the data in the cache could become stale. It could be inconsistent with the database. So a good cache has to factor all of those situations to make sure that the cache is always fresh. Because if it isn't, then you're going to use the cache for very limited, mainly for read-only data, for lookup tables. That's about it, which is probably not. Majority of your data is not reference data. Majority of your data is transactional data. These are your customers, your accounts, your activities. For example, we've got one of the leading banks using NCache for a bank wire application. So every time a bank wire is sent, it's stored in the cache for some period of time. So that wire could represent a lot of money. So you don't want the data to be wrong. You don't want the customer to withdraw $1 million twice. Although the customer would like it, but you definitely don't like as a bank. So that's the biggest concern. In the other two use cases, the biggest concern is that the only place the data exists is in the cache. That means the cache is the master. Master means the cache cannot lose data. So unlike disk, where you don't lose data, memory is volatile, so replication becomes really, really critical in these two use cases. Okay, so let me now dive into the actual topic after this sort of an introduction. So when you're using entity framework applications, there are two ways that you can plug in a distributed cache. The first is that you just make API calls. You get the entities from entity framework. Entity framework itself has an L1 cache, which it flushes out. But once you've gotten the objects, the entities, you want to cache them, so the next time you don't have to go to the database. So you don't even make the entity framework calls. The second is that you don't want to make any code changes. In case of Hibernate has a second level cache pluggable architecture. So at entity level, they allow you to plug a third-party cache. So you could plug in NCache or Redis or any other cache of your choice. But entity framework does not have that architecture yet. I think we're hoping in EF7 because they're completely re-architecting this product, that they're going to provide a pluggable architecture, so that by having the cache plugged in at entity level gives you a lot of control without having to do any programming. But so currently the only way to plug in a cache to entity framework without programming is by having a custom ADO.NET provider, which is what NCache does. But I don't recommend that you go that route. If you have luxury of time where you can do a little bit of programming, do the programming, make the API calls. So for example, here's a sample of NCache API call. This looks remarkably similar to the ASP.NET Cache object API if you look at it. And once we go into more detail, you'll see that it looks even more so. By making calls, you have total control over what you want to do, when you want to update the cache, when you want to expire objects, what do you want to cache, what you don't want to cache. So I would highly recommend that you use this methodology instead of going with the pluggable. So a cache is like a database. It's an in-memory database. There's a connection that you make. In case of NCache, it's called NCache.initialize cache. You provide a cache name. All caches are named. It gives you a cache handle. Other caches would have similar paradigm where you would get the cache handle. And then you use the cache handle in your application to do your fetching data, writing data, updating data. All the keys are string-based in case of NCache. I think even in case of Redis, they're string-based. And the value is an object. In case of NCache, it is any .NET object. I think in case of Redis, they convert everything into a string, so their value is a string. Any questions? So when you're going into the entity framework, let's say you're going to take the approach of programming, you're making the API calls. So what are the things that you need to make sure that you do? So first of all, every object that you want to cache has to be serializable. So when you generate those entities in EF, make sure that the serializable attribute is there. If not, then you may have to modify the templates to do so. The second thing that you want to do is make sure that lazy loading is turned off, because if you don't, then when you, let's say if you want to cache a customer object and this customer has a collection of orders and you don't want to cache that collection of orders along with the customer object, if the lazy loading is turned on, as soon as you serialize the object, it's going to serialize all of the related objects along with it. So make sure that this is turned off. If you're using POCO, the plain old C# objects, and you had lazy loading in POCO, the only way to do it is through proxy. So a proxy is not a known type. It's not a type that is known at compile time. So you cannot serialize a proxy. So one way is to not use proxies when you want to cache anything, because otherwise you won't be able to cache it. You won't be able to serialize it. Otherwise, if you want to use proxy and you still want to use serialization, so there's a proxy data contract resolver class that comes that can resolve the dynamic proxy type into, it maps it to the actual POCO type. And that's how you can serialize it. Another thing that you want to make sure in entity framework is you have these anonymous types. Here's an example of an anonymous type. So if, you issued a query which is a join of multiple collections. So the results that you're going to get is an anonymous type here, which has attributes from multiple objects, multiple tables, and the anonymous type again is a dynamic type. It cannot be serialized. So, and if your application is using anonymous types and you want to use caching, then you want to convert them into known types. So they're called data transfer objects. So you actually come up with a customer object, a custom object that represents this data. I'm calling it product supplier DTO. So it's got all the things. So this becomes a known entity, and then you can serialize it. If you can serialize it, you can cache it. So those are the 4 things that you need to keep in mind before you start making API calls into any cache. Any questions on this? I'm going to make these slides available after this talk, and have you guys download them from there. Okay, so here's a very simple code example of how you would use caching in an EF application. You've got, so let's say you're trying to load a customer object based on a string-based customer ID. So you want to check the cache first, and you have the cache handle already because you made the API call, you connected to the cache. The cache handle is somewhere preserved in your application. You construct a key. The key is, notice the key here, it contains the type information. It has the customer and the customer ID and the actual value. So this is a way to define a unique key that represents this specific customer. So you check the cache first. If the cache does not have this customer, then you go to the database. So it's just a very simple, code. You get your context. You go to the customer. You based on your customer ID, you get that specific customer and you cache it, and then you return the customer. So the reason you cache it is so the next time you come here, you will find it in the cache. So this is a very simple use case of how you would make the call from an entity framework application. It's no different than if you had any other application, except here you're getting the stuff from entity framework. So you're putting the caching calls at the layer above the EF itself. So it's within the application code that is calling EF that you're making the caching calls. Go ahead. The key is, in case of NCache, it is case sensitive, or no, actually in case of NCache, it is not case sensitive. I don't know about Redis. It's always a good idea not to use a case sensitive key, because if you switch from one caching provider to another one, your application may break.
So how do you ensure that your cache is not stale?
Okay, so I'm gonna get into that in a bit. This was just, I'm just sort of slowly moving into this. Another way to do the cache is, let's say, so this was the individual object, here's a collection. It's a very common thing to go and search the database to get a collection of objects or entities back. So when you get a collection back, what do? There are two things that you can do. One, you can cache the entire collection as one object in the cache. Collection is also a .NET object, so the entire collection will be serialized and cached. In this case, or what you could do is you could say, I want to cache in every object in the collection separately, so that later on, if I want to update that specific object, I can update it in the cache, and then whenever I want the collection back, I'm just going to make a call. In case of NCache, there are a number of ways that you can associate all those objects together as one logical collection and then fetch it back. In many situations, it's probably a good idea to cache the entire collection as one object, because you're caching it only for a small period of time. As I said, if it's a transactional data, you're probably caching it for a few minutes, and then afterwards it's going to go away. So you either cache the entire collection as one object, or you cache every object in the collection separately. And when you're caching them separately, in case of NCache, then you can use this feature called tags. So every object that you're caching has the same tag, and that later on, if you wanted all those objects back as one collection, you would just say, get me anything that has this tag. And that tag could be any logical name that you want to give it. I'll come back to this, but let me go into some of the stuff that is actual caching stuff. So when you're caching, there are two types of data that you cache. One is reference data, which does not change very frequently, but it does change. It's not a read-only data. You can cache it without worrying about it going stale for hours, if maybe days. The other is transactional data that I talked about. So when you start caching data, what are the things that the most important thing to keep in mind is how to keep the cache fresh, right? So because in application data caching, the data exists in both places. So how do you keep the cache fresh? Which is, a lot of people have this misconception that a cache cannot be kept fresh. The only way to use the cache is to use read-only data. A lot of people do not venture into transactional data. The reason is because they don't know what cache can or cannot do. Because without caching, in the old days, you just had a table in memory and you just put stuff in it. So that was your homegrown in-proc cache. So you obviously cached only stuff that was read-only, because you didn't want to build the logic to keep track of stuff. But distributed caches have a lot of sophistication in them, so they are able to, keep track of this. So expressions, so there's absolute expression and sliding expression. Let me quickly show you, for example, if I were to, I'm going to come here. Oh, this is really, just one sec. I just need to quickly change the resolution. I think it's too. Okay. Are you able to see this? Are you able to see this? Can you see this? Okay. I can make the font bigger. I can make it 200%. That's probably better, right? Okay. So let's say I want to go and see how the expirations are done typically. And I'm going to, of course, use NCache as an example, but you can go with your distributed cache of your choice. So here's some. So first of all, in a typical caching situation, you would every cache has a client library that you would reference. So for example, in case of NCache, you're going to reference these two libraries. There's a ncache.web and ncache.runtime. We chose ncache.web to be similar to the ASP.NET cache object in the old days, and then we just kept the same namespace. So, and then you would specify the namespaces that you need, and once you have that, then you go ahead and at the beginning of your application, you get a cache handle based on the cache name. And now that you have the cache handle, you want to add something to the cache. You probably don't want to do this, in fact, you definitely don't want to do this. So you've got your object, you've got the object has values, and now you're caching it. So here's cache.add, it takes a key, here's the actual object, and then now you can specify expiration. So here's an absolute expiration. So it's saying keep this for 10 minutes. So it's a date time value, you're keeping it for 10 minutes, and that you're going to do that. You're going to do that for permanent data. So any data that's coming from the database, you will use absolute expiration on it, because you're making a guess on how long it's safe to keep it in the cache. If you had transient data, you will probably use sliding expiration. The difference between these two is that in absolute expiration, it will get expired regardless of whatever you do. In sliding, it will not get expired unless you stop using it. So you would go ahead and again, instead of specifying this, now you're going to specify the sliding expression, and then you say, I don't want any absolute expression in this. So this is how you would go ahead and specify expirations in a typical cache like NCache. Again, notice that you're doing this at an object level. So every object will have its own expiration, so it gives you total control about which objects to expire when. Any questions on this? Okay. So that's the first way that you keep the cache fresh. The second way is to synchronize the cache with the database. Some other application might go and update the data directly in the database. So one way is to use a SQL cache dependency that is a SQL Server feature. Here's how you would use that. In fact, I think I'm just gonna. Again, so you've got your cache handle, and you will specify a SQL statement. In this case, this SQL statement maps to only one row in one table. And you will say, this is my SQL cache dependency, and you will specify this dependency as part of the cache.insert. Cache.insert means add this object if it doesn't exist in the cache, otherwise update it. So this dependency means that this item in the cache will be removed from the cache when this row in the database is either updated or removed. So if somebody goes and updates this row in the database, NCache, in case of NCache has become a client of the database. It is monitoring the database for any changes. And this is so the database sends a database notifications, which are events, and NCache will receive those events, and NCache will say, okay, I have this object or this cached item with this key mapped to this SQL cache dependency. So I'm going to remove that item from the cache because database is telling me that this corresponding row in the database changed.
So let's say the same product object was a child property in some other nested graph. When the product is modified in the database, only this key will be basically expired. But the same product could be still in the cache as part of the next object somewhere else.
Okay. So the question was, if there's more than one cache item that is dependent on this row of data, what would happen? In case of NCache, you can specify this dependency with every object. Other caches don't even provide this feature. So, as far as the NCache is concerned, yes, you can have, if you have the same product object occur in multiple places in the cache, specify this dependency everywhere, and NCache will remove all of them.
You need to specify multiple SQL statements that all will result in.
Actually, so the SQL statement is one, but the same SQL statement can be used for other places. So let's say if you have another place, as you said, that this product object is being cached at another location in the cache, and it may be embedded in another object, or it may be separately cached. So you can specify the same SQL statement there as long as you're caching the object independently. Yes?
Can I use stored procedures?
Yes, you can use stored procedures also. Yes?
Is that only available on SQL Server 2014, or can you use older SQL Server versions?
You can use it, so it can be used with any SQL, I think SQL Server 2005 onwards, you can use it. Yeah, because the SQL cache dependency feature is a pretty old feature. And in fact, you can even use it with Oracle. If you have an Oracle database, Oracle has a similar Oracle dependency that NCache supports, and it does the same thing, allows you to monitor the cache.
How does that work, like with more complex objects that may, pull from multiple entities in the database and combine them in, a separate, join, storage and cache?
Right. So the SQL cache dependency has a limitation that you cannot specify joins in it. That's a SQL Server limitation. So what you can do in that case is identify one part of that data and say, if this data changes, remove the entire complex object from the cache.
You can register all the different parts of it.
With one object, so the question was, if the object that you're caching is complex, it's coming from joins of multiple tables, how do you do this? And since SQL cache dependency does not allow you to have joins, the only way is to pick one of those tables and map it and say, if this data changes, remove the cached item.
So the answer is you can't have multiple dependencies based off of one object. So in other words, let's say, in this example, it consists of 5 different rows in different tables, and one of those rows changes in any one of those tables. And you have specific dependencies on all of those tables pointing to one object.
I think in case of NCache, you can have more than one dependency. I don't remember on top of my head if they can all be SQL dependencies or not, but
So you could specify right there, let's say 5 different rows of dependencies that all have separate, so long as there's a foreign key associated in those additional tables. Is that true?
I think, so the question was, can you have multiple dependencies specified against one cached object? I think in case of NCache, you can have multiple dependencies. I don't know on top of my head if you can have all of them as SQL dependencies or not, but I would say that you can. And if you can, then each dependency has its own SQL statement.
So you said earlier that you could do the dependency on a stored procedure. That stored procedure could have to join it. Is that not true?
take my statement back. I think the stored procedure, I'm not sure if SQL cache dependency allows you to map things to a stored procedure or not. My apologies.
On the same topic, so for the statement that we have, can you compose a statement with multiple selects, like product ID from product pair, and then you with the semicolon you write another statement? Can you do that and have, let's say, 5 statements? They all point to the same dependent object. Is it possible?
I think the SQL cache dependency has a limitation that you cannot have multiple unrelated statements. But you can have multiple SQL dependencies. So there's nothing that's stopping you from having multiple SQL dependencies. Good questions. Okay. So that is one way of synchronizing. But keep in mind that if you have a lot of data in the database, let's say if you have 100 million rows, or let's say if your cache has 100 million items, you definitely cannot have 100 million SQL dependencies created. Your database is just going to die. So there's a limit to how much. So that's the other part, because we're talking about scalability. We're talking about environments where you have a lot of transactions, a lot of activity. You have to keep that in mind. So SQL dependency is good, I would say, for thousands, tens of thousands of SQL dependencies. But if you're going to go into hundreds of thousands of SQL dependencies, it's better to adopt a different strategy. And another strategy is DB dependency, which is, in case of NCache, that is NCache's own implementation, which is that NCache pulls a specific table, and then sees whichever rows change, it goes and removes the items from the cache. Even DB dependency has limitations, because that table could be really, really big, right? So then the third option is CLR procedures. CLR procedures is something that you call from your database triggers. So let's say if the customer object is being updated, you call the update trigger. The update trigger makes an NCache call. The only thing I would recommend highly is that do not make synchronous calls, make async calls, because these calls are being made from within a database transaction, which can time out pretty quickly. So a CLR procedure. So those are different ways that you can keep the cache synchronized with the database. And if you have non-relational data, then you can do similar things. There's a custom dependency, which is your code that monitors a data source. And finally, if you have relational databases, that one-to-many thing, if you have a customer which has a bunch of orders, if you're removing a customer from the cache, does it mean that you're probably also removing it from the database? Although you don't remove a customer, but I'm just saying one-to-many. So it's always safe to remove the many side from the cache. So, when you have that type of a relationship, you want the cache to handle this. So, it would be good if you just specify. There's a cache dependency feature that was there in the ASP.NET Cache object, and NCache also has it, where you can specify the one-to-many relationship, and the cache will automatically remove the related objects from the cache if the object on which they're dependent is updated or removed from the cache. So those are the ways that you make sure that the cache is fresh. The most important thing in using a cache. With these features, you should feel pretty confident that you can cache pretty much every data. The only time something does not make sense to cache is when you know it's going to change every second. And actually, even there, I will correct myself. Session state changes in matter of seconds. Every time there's a web request, a new session state is updated in the store, and the store could be the cache in this case. So even there, the cache is a much better option than the database.
You talked about cache. Is the only advantage of using this instead of using ASP.NET in-memory cache is that it's distributed, or is there any other advantage?
So fundamentally, if your application runs in a so the question was, is there any advantage to using a distributed cache over a standalone cache like ASP.NET Cache? If your application is running in a multi-server environment, you need to keep the cache synchronized. If you don't, then you'll only use it for read-only data. And that, we've talked about that. So having a common cache that is synchronized is the minimum requirement. So this next thing is, okay, now that you have a common cache, is it scalable? Because it's not just about performance. I mean, databases are pretty fast. If you only had 10 users, I haven't heard of anybody complaining about database performance. So where does the performance problem start? It starts when you have a lot of activity. If you go back to this part. So then the cache has to be distributed to scale. If it's not distributed, it's not going to scale. And scale in terms of what does scalability mean? It means it should be able to store a lot of data. So the more servers you add, the more storage capacity you have. And second, it gets more CPU. More CPU means more transactions per second. So these numbers that I was saying, you can go from 50,000 to 150,000 requests per second by adding more servers. So that's why it's important to have a distributed cache. Distributed cache pretty much has become a best practice now. Microsoft App Fabric, even though the product turned out to have issues, and that's why they've discontinued it and adopted Redis, at least in Azure, it validated this concept. One of our biggest problems used to be that when we talk to the customer, says, what's caching? And again, it would come down to, well, we're caching our read-only data in our standalone.
So even with this form or garden environment, you could specify your sections or your cache outcrop mode, and that way your caching is actually persisted on a storage. And actually, you could I think hook up some different framework which will basically do the outcrop cache. Is it like any better than the outcrop solution because it's in memory and the outcrop is persisted in a database? So you could achieve the same result, like having multiple servers share the same capability.
So the question is it better to use an outcrop cache as a storage for ASP.NET session state than the options that Microsoft gives us, which is state server and SQL server? Definitely it is. It's all in memory. A distributed cache does not persist data. If it's going to persist, then it's not fast and scalable.
Do you have any numbers that maybe benchmark?
So these are the numbers, as a sort of a baseline. And then you can extrapolate based on if the data size is larger. These numbers are with 1K of data in each cached object. So in most situations, when you use a distributed cache, you will do benchmarking, or at least you should do benchmarking before you deploy it. And most distributed caching solutions provide you with a very easy way of doing benchmarking. I know the NCache does. We give you benchmarking tools that our customers tested in their infrastructure to make sure that it meets their needs. I'm going to speed up because otherwise I won't get to the. Once you start to cache a lot of data, cache is becoming a database. It's no longer just a key value store is not sufficient. So because you cannot remember all the keys, if you had to do all your database programming based on primary key values, imagine how difficult life would be. So you want to be able to search based on attributes. So you want to say, give me all the customers where customer.city equals New York, so you can get a collection. So having the ability to do SQL type of searching is very, very important if we're going to cache data. And again, let me show you. So for example, here's some source code that shows you how to do some search with LINQ. So again, you've got all these are console applications. So you've got your iQueryable collection. So this is your LINQ implementation of NCache, and then you can go and do your LINQ searches based on your criteria and get back a collection of products. So you can do those types of searches, and you're actually searching the cache, not the database. And you want to have that ability to search the cache either through LINQ or through SQL, or SQL type of a language. And because when you do that, then you can start to cache data. So let's say if you were to cache all that reference data, how do you search the reference data? How do you fetch the reference data? Not based on primary keys, right? It's based on whatever other criteria you have, price, product, or whatever else. Maybe the categories, maybe, you know. So ability to search is very, very important. Then another way to make it easy for you to find data is by doing groupings. Because again, it's a key value store. Whatever the value, it could be an object, it could be plain text. So it's good to have some way of putting the group. I gave you the example here that you're caching everything, but you're putting in a tag. So that later on, you could fetch everything in one call and say, give me everything that has this tag. So this is kind of like the metadata that you attach to the cached items at runtime. Read-through, write-through is another very important feature that NCache provides. Also, some of the caches do. And read-through is your code and this is where, if you were to go back to this picture, if you want to go through the cache, where you read the cache and the cache gets the data from you, from the database for you, how does the cache get it? The cache doesn't know your database. The cache is just a standard product. So the cache calls your code. That code is called read-through. So let me show you what read-through looks like. I can just read this there. So for example, you would implement an iReadThrough provider in case of NCache. This wants you to implement 3 methods. There's an init method, which is called when the cache is started. So it kind of initializes all the things for the read-through to be, because your read-through is probably going to connect to your database or your data source. So that's being done at init. And at the end, it's like the disconnect. And load from source is like the get method. So it gives you a key, and it wants you to give it back a cached item in case of NCache. And this cached item is your actual customer object plus some other metadata, so expiration information or anything else that you want to specify. You can specify that in the read-through. And so this code is called by NCache, and NCache will call it, let's say your application does cache.get, specifies a key, and the key is not in the cache, and you have a read-through handler. So that's when NCache will call the read-through handler, so it can go and get the data from the database. Same thing goes with the write-through, exactly same way. The only difference with write-through is that you could do a bulk update also. So the write to source could be just one operation, or it could be an array of operations. And if I were to come back here, there's a variation called write behind. So the write through is done synchronously, which means your application waits until the database is updated. Write behind is when your update gets queued up. The database portion of it gets queued up and then is applied separately. And then you can combine read through with features like expirations and database synchronization. So on expiration, instead of removing the item from the cache, if you have a read-through, why not just reload it? Because if you don't reload it, your application is probably going to want it pretty soon anyway. So a lot of your reference data that needs to be refreshed, instead of expiring it, you just reload automatically. And that's something that through read-through, NCache will do it for you. The same goes for the database synchronization. I'm going to quickly go into what a typical distributed cache architecture looks like, and I'll use NCache as the example. Again, NCache is an open source cache. It's Apache 2.0 license, you can actually, oh man, this is, so for example, you could either download NCache Enterprise, which is a fully day working trial, or you could go to open source, or you could go to GitHub and just get the source code. So it is open source. So there are a few things that a good distributed cache must provide, and if you're considering using the distributed cache, you should know what they are. Number one, it needs to provide high availability, and the only way it can do that is if it has a dynamic cache cluster. Dynamic means it can change at runtime. You should be able to add or remove servers at runtime without stopping either the cache or the application. And that is only possible if you have peer-to-peer architecture and if you have dynamic configuration. Dynamic configuration means you don't hard code things into files. You propagate things at runtime. So whichever cache you pick, make sure that it has that capability. NCache definitely does. And then caching topologies are different storage and connection strategies. So there's 4 of them. I'm going to skip to the first 2. The first is called the mirrored cache. It's a 2-node active passive. There's the active, and there's the passive is the copy or the mirror. Then the replicated is where every node in every cache server has an entire copy of the cache. So the more servers you have, the more copies of the cache you have. The third and the fourth are called partition cache and partition replica in case of NCache. And this is the most popular topology with NCache because this is where it gives you the scalability. So partitioning, the entire cache is broken up into partitions. Every partition has, let's say in a case of a 2-node cluster, half of the cache. There's a distribution map, which is really the bucket map. So it gets propagated to all the clients at runtime. So that way the clients can now connect to all the servers and go directly with the data. So if this client wants item number 1, it's going to come here. If it wants item number 3, it's going to come here. Partition replica is the same as partition, except every partition is replicated. Replica is passive. No client talks to replica. And that way the partition can update the replica either asynchronously or synchronously. Async is the default. It's pretty fast, but sometimes you need sync replication. The reason you need sync replication is because the data might be very sensitive. As I said, that bank wire application, you don't want that update to be lost. In case of a synchronous replication, the application will immediately be notified that that update failed. So having these 4 caching topologies gives you the flexibility, and partition replica is our most common topology. It gives you the best of both worlds. It does partitioning and replication both. Every partition is backed up onto a different server, and that way you don't lose any data. But it's very scalable. Let me give you an example. Let's say if you had a 3-node cluster, and 1 server goes down. They just go backwards. So partition 3 goes down and replica 3 goes down. So now you have 2 servers where partition 1, partition 2, and there's replica 3 is here and replica 1 is here, right? So now it needs to become this. So what's going to happen, replica 3 becomes active. All the clients talk to it, but now it starts to merge itself with these 2 partitions. Once that merging is completed, a replica for partition 2 is created here. All of that is done at runtime. And this dynamic, that's what the dynamic nature is. A distributed cache must provide this capability if it's going to be highly available. And a cache that is not highly available is like having a database that keeps crashing all the time. Who wants that? And the distributed cache has the extra sensitivity because it does not have a disk storage. Everything is in memory, so replication is a very, very key portion of it. One more thing, which is the client cache feature. This is a very important feature. Some people call it near cache. NCache calls it client cache. It's a local cache. So this could be an in-proc cache that you were talking about, except it is not standalone. It is connected to the caching tier, the cluster here. And this connection is all transparent to the client. The client doesn't even know the client cache exists. It talks just as if it's talking to the clustered cache. You just plug it in case of NCache, you just plug it in through configuration change, and the client cache automatically caches data on the client end. And this, if it is in proc, that means it's going to cache data in an object form. So those objects are being kept on your application heap. And that means that when you fetch them, they're super fast. There is no serialization cost, which in a distributed cache, serialization is a huge cost. So a client cache is really a cache on top of a cache. And it's good when you're doing more reads than writes. It gives you super performance. And also scalability, because you're reducing trips to the caching tier, and the caching tier is reducing trips to the database. It's like a multi-layer thing. Finally, I think this is probably one of my last slides. WAN replication. See what time is it? So we've got 3 more minutes. WAN replication is something, if you have multiple data centers, you want the cache to also have the ability to replicate just like your database can. Why shouldn't the cache be able to replicate as well? And it should do it in a way that does not slow down the active caches. And it needs to do conflict resolution and if it's an active situation. And this is what NCache does. I'll skip the hands-on demo. I'll skip the fact that we're really popular. And I'll go into NCache versus Redis. Redis is something that Microsoft picked for Azure, and they've also ported it on Windows. Yes, they ported it on Windows. But interestingly, they're using the Linux version in Azure. And we've heard a lot of complaints about the Windows port, which is not being officially supported by Redis Labs. If you go to Redis Labs website, they don't even have a Windows download, so it's all Linux. NCache is also open source, just like Redis. It's Apache 2.0. NCache is purely .NET, so if you have a .NET application, it makes a lot of sense to have a .NET stack. If you don't have the money or you don't want to spend money, don't spend money, just go with the open source version of NCache. There are a lot of features that NCache has. I went through some of those features that none of the other caches in the market, at least on the .NET side, and that includes Redis, they have. The Java side caches have those features, those in-memory data grids, but the .NET side caches those. So all these features that I'm talking about, caching topologies, WAN replication, GUI admin tools, security, encryption, SQL searching, grouping, read-through, write-through, database synchronization, relational data, these are features that Redis does not have. ASP.NET session state Microsoft has implemented, so that is wrong here. It's outdated. But they don't have view state. They do have output cache. They don't have view state. But you can do the comparison. If you come to our website, there's a detailed comparison that you can take a look at between NCache and Redis. And you can download it. By the way, red and blue is not good. Green is good. So that's the end of my talk. Any questions? So on the .NET side, you have AppFabric, you have NCache, and Redis is not a .NET cache, but because Microsoft is using it, so I have to say it is available, at least in Azure. So those are the ones I know. My apologies. I'm going to have the slides. How do I make the slides available? I'll have it at alachisoft.com/vslive .ppt. The actual slides. So I'll upload it and I'll call it vslive.ppt. All lowercase. Thank you very much. Yes, please.